Ever thought about how a computer can recognize your face or voice? The answer lies within the intriguing world of artificial intelligence. This revolutionary technology, often simply known as AI, is swiftly becoming an inseparable part of our everyday lives. It's in our smartphones, powering virtual assistants and predictive text. It's in our homes, making our devices smarter and our lives more convenient. Artificial intelligence is essentially a field of computer science that aims to simulate human intelligence processes. It's about creating systems that can understand, learn, plan, and problem solve. This is achieved through complex algorithms and models, enabling machines to mimic human thought patterns and decision-making processes. The scope of AI is vast and ever-expanding, with countless possibilities and applications. But to truly appreciate the magic of AI, we need to understand its inner workings. Now that you have a basic understanding of AI, it's time to delve deeper into one of its remarkable components, the neural networks. What really are neural networks? Can a machine actually learn like a human brain? To answer these questions, we need to first understand what a neural network is. Picture this: an intricate web of interconnected nodes, each one playing its part in a vast, complex system. This is the essence of a neural network, an algorithmic construct designed to mimic the way our brains function. You see, just as the human brain is composed of billions of neurons, each connected to others through synapses, a neural network consists of multiple layers of nodes or neurons, each interconnected in a similar fashion. So how do neural networks resemble our brains? Well, the magic lies in the connections between these nodes. Just like synapses in our brain, these connections have weights, which determine how much influence one node has on another. Interestingly enough, these weights can be adjusted, allowing the network to learn from the data it processes. Our brains process information by transmitting electrical signals between neurons. Similarly, in a neural network, information in the form of data is passed from node to node. Each node processes the data it receives, applies a transformation, and then passes the result onto the next layer of nodes. Now, you might be wondering, if these networks mimic our brains, does that mean they can think and reason like us? Not quite. While neural networks can learn patterns and make predictions based on those patterns, they don't understand the data in the same way we do. They don't have consciousness or self-awareness. They're tools designed to help us make sense of complex data, to recognize patterns and make predictions. However, it's important to note that while they can't think like us, they can learn and adapt. They can improve their performance over time, refining their predictions as they process more and more data. This ability to learn and adapt, to train themselves, is what makes neural networks such a powerful tool in the field of artificial intelligence. So neural networks learn and adapt, much like our brains, but how do they do it? How does a neural network learn? It's all about training, just like how you train a dog to follow commands. Now let's dive deeper into how this training process works. Picture a neural network as a newborn baby. Just like a baby, it doesn't know much about the world, but as it grows, it learns from the environment around it, starting to understand and adapt. Similarly, a neural network starts from a point of knowing almost nothing. It needs to learn from a large amount of data that we feed it. This data, known as the training data, is a collection of examples that the network uses to learn. For instance, if we want our neural network to identify images of cats, we would feed it thousands of cat images. Each image is labeled with the correct answer, in this case, cat, and the network makes a guess. Initially, these guesses might be wrong more often than not, but that's okay, because each mistake is a learning opportunity. The real magic happens when the network adjusts itself based on these mistakes. It uses a process called backpropagation to adjust the weights and biases of its neurons. And what are these weights and biases, you ask? Well, think of them as the network's way of making decisions. By adjusting these weights and biases, the network changes how it interprets the input data, making its guesses more accurate over time. This process is repeated many times over. Each repetition, or epoch, improves the network's accuracy. It's a bit like practicing a musical instrument. The more you practice, the better you get. That's how a neural network learns. It's important to note that training a neural network is not a quick process. It can take days, weeks, or even months depending on the complexity of the task and the amount of data. But the results can be truly extraordinary, enabling the network to perform tasks that seemed impossible just a few years ago. So training makes a neural network smarter. But what happens when it makes a mistake? Nobody's perfect, right? Not even a neural network. But the beauty of it lies in its ability to learn from its errors. Imagine setting foot on a path you have never walked before. It's dark and you stumble. But as you keep walking, you start to remember where the pitfalls are and navigate around them. This is akin to how a neural network learns. It stumbles, it trips, but with each error it learns a little more about the landscape of the problem it's trying to solve. This process is known as backpropagation. It's the cornerstone of learning in neural networks. When the network makes an incorrect prediction, it calculates the difference between its prediction and the actual result. This difference or error is then fed back through the network, adjusting the weights and biases of the neurons along the way. Imagine a neuron that consistently contributes to wrong predictions. Backpropagation will reduce the influence of this neuron in the network's calculations. Conversely, a neuron that consistently contributes to correct predictions will have its influence increased. Over time, this process helps the network improve its predictions. But this isn't a one-time process. A neural network will often run through thousands, if not millions, of iterations, constantly learning and adjusting. It's like a pianist practicing a piece of music, starting off clumsy and discordant, but gradually, through repetition and correction, becoming more and more adept until the music flows beautifully. Sometimes a network might learn too well from its errors, leading to overfitting. This means it becomes excellent at predicting the data it has been trained on, but performs poorly on new, unseen data. It's like studying for an exam by memorizing the answers to past papers, but failing when presented with new questions. To avoid this, we use techniques such as regularization and dropout. The more mistakes a neural network makes, the more it learns. And that's what makes it so fascinating. The journey from stumbling in the dark to confidently navigating the path is an extraordinary process to witness. And that, ladies and gentlemen, is the intriguing world of learning in neural networks. So, where do we actually use these neural networks? You'd be surprised to know how integral they are to our everyday life. Indeed, neural networks have transformed various sectors, from healthcare to finance and beyond. They are the invisible companions, working tirelessly in the background, making our lives easier, more efficient, and, dare we say, more exciting. Take healthcare, for instance. Neural networks are used in disease diagnosis and drug discovery. They analyze a vast array of medical data, identifying patterns that might be overlooked by human eyes. This increases the accuracy of diagnosis and speeds up the development of life-saving drugs. In finance, neural networks are used for credit scoring, fraud detection, and stock market prediction. They are capable of analyzing complex economic patterns and making accurate predictions. This helps financial institutions make informed decisions, save resources, and maintain market stability. In the field of robotics, neural networks are used to enable robots to understand and learn from their environment. This allows them to perform complex tasks and adapt to new situations, paving the way for a future where robots can assist us in our day-to-day tasks. Even in our homes, neural networks are at work. They power our virtual assistants, helping us schedule appointments, play our favorite music, and even control our home appliances. In the realm of entertainment, neural networks are used in game development, creating more realistic and immersive gaming experiences. They also assist in movie recommendations, learning our preferences and suggesting films we may enjoy. On the roads, neural networks are the driving force behind autonomous vehicles. They process a multitude of data in real time, helping these vehicles navigate the streets safely and efficiently. In essence, neural networks are not just a fascinating concept of artificial intelligence. They are practical, powerful tools that are reshaping industries and redefining the way we live and work. From recognizing faces to predicting stock prices, neural networks are making our lives easier and more efficient. So, the next time you ask your virtual assistant to play your favorite song, or when you see a self-driving car pass by, remember the marvel of neural networks working behind the scenes. So that's a brief overview of the fascinating world of neural networks. We've embarked on a journey through the intricate structure of these networks, dissecting their hidden layers. We've seen how they learn, adapt, and evolve through training, making sense of the vast data around us. We've delved into their ability to learn from errors, constantly improving and refining their understanding. And we've touched upon the myriad of applications these networks have in our lives, from facial recognition to disease prediction and even stock market forecasting. Neural networks are not just a technological marvel, they are a testament to human ingenuity. They mirror our brain's processing, revolutionizing the way we interact with technology and the world around us. They are transforming our present and shaping our future. Thank you for watching. Don't forget to like and subscribe for more enlightening videos about AI and its amazing applications. See you in the next video.